Pauline Barrieu, Professor at the Department of Statistics. Your work seems to be concerned with models and modelling and so on. And reading you, I get the impression there's never a right model, You do the model of the models and there's, model averaging, ambiguity aversion, robust control and so on. But you seem to now be saying that you've got the right model. What is it? And why should we believe you and nobody else?
I will not pretend I have the right model. I think, however, it's very important to be aware that many models can exist at the same time, and many opinions. Experts may give you different opinions. You might have different views on the same event, on the same situation, and I believe it's very important to take into account all these in order to assess a situation and maybe to take a decision.
So what you do is you grow your approach based on the fallibility of other models. Is that it, more or less? You acknowledge the wrongness of models, which is your starting point for being right.
No model is right, but there are some models which are less wrong than others. Mm-hmm. And I do believe this. I believe that there is some good in all models, some information, some good things that we need to take into account in everything.
Now, your modelling comes from your disciplinary background, I suppose, statistics, does it? Would that be fair, that it's sort of rooted in an understanding of stats, which is what leads you to be confident that you can produce a less wrong model than others? But do you think sometimes that each of our models grows out of whatever our discipline happens to be? That models are siloed. The economists have theirs, the economic historians theirs, and here come the stats people with theirs.
That's where I think it's very, very important to go multidisciplinary or interdisciplinary. And something I find really, really interesting is to see how people work in other fields, whether it's in economics, sociology, even medicine, immunology, epidemiology. To
see how wrong their models are.
No, to see how they approach the fact that their model may not represent all aspects. Mm-hmm. And to take this into account and maybe apply same principles to other disciplines.
And what are the principles that stats brings to modelling which make it, and I don't think you've disagreed with me, superior to other modelling? What are the virtues in stats?
Oh, I do not believe statistics is superior to other disciplines.
You have to say that, but no.
What I believe maybe is that statistics has a kind of systematic approach to modeling. So doing stage by stage, which can be appropriate for other disciplines, like notations, for instance, the language, thinking about a common language, which is also very important. I do not believe, however, that statistical models are superior to all other approaches.
Just none of the others have been found yet. And it actually works for you. You've written about old age, you've written about weather. Is there anything that cannot be modelled from your perspective?
That's a difficult one. I remember being a student, like a first-year undergraduate student, and attending a microeconomics course where the professor was explaining about how to put marriage in equation, and I was a bit shocked. So I guess there are things that you cannot really model with equations. However, modeling does not necessarily mean equations, and you might have experts' opinion, and it can be qualitative modeling. So it does not need to have an equal sign to be a model.
Now, one of the things you're really aiming for, I think, is implementation. How can you turn your models into realized mechanisms in culture? Because presumably you want to do that, because after all, complexity is against you, isn't it? Your models are hard to follow. People need to concentrate. How do you turn them into something which happens?
So obviously it depends on the application you're looking for. I would say in some of my research is related to financial markets, and people in financial markets tend to be quite quantitative, and so there shouldn't be too much of a problem for them to follow equations. However, there is this tendency in the past that was really towards being optimal in a way, so using a model and pushing it to the limit to find the optimal solution. I think these days the tendency is more towards robustness, so you have different ways of defining robustness, but this concept of whatever happens, even if you get your model wrong, what you are following as a principle is still valid in a way. And I think this is a new tendency, probably in financial markets, a tendency that has been around for many years in engineering. When you build, I don't know, the motor for a plane, the engine of a plane, you need to have something robust, not optimal. And so this is probably what is happening in financial markets.
A model that it might be tempted to make a bit of money out of. The word derivative crops up in your work, and here you are as an academic. Do you ever feel tempted to turn your work into a realizable material benefit for yourself, or are you happy as an academic here at LSE?
I'm taking full benefits because it's the freedom of thought, so which is the best place to be.
Pauline Barrieu, thank you so much for submitting yourself to the C.Gearty grilling.
Thank you very much.